Okay, so do you remember from the previous class, in order to model a wind generator, we need to split up in many components, right? So for instance, this is the doubly fed induction generator, okay? So in order to carry out the model, first of all, I will model the wind, okay? How to model the wind? I have two methodologies. The first is the stochastic, and the second one is the deterministic methodology, okay? Later on, I will take into account the rotor blades, okay? This is aerodynamic. And then I want to model the gearbox, and then the generator. In this case, I will have a machine, and this is the doubly fed induction generator. And then I will model the power electronics, the power transformer, and finally the power grid. That is the way in order to model the doubly fed induction machine. On the other hand, if the machine is broken down in many components, I will have, for instance, here my first component. Okay, this is the wing model. What is the output? The output is the wing speed. Later on, I will have my second block. This is the aerodynamical model. This is for modeling the blades. Okay, what is the output? For this case, okay, so for this case, the output is the torque. Okay, and then I will analyze the gearbox. For this case, the input is the torque and the output is the torque too. Okay, so later on I will analyze the next block. Yeah, this is the generator model with the power side converter. Okay, I will take into account this converter. This is for the grid side. Sorry, this is for the stator side, and this is for the grid side. In order to connect this machine to the power grid, what I need is a 3-winding transformer, okay? This is the 3-winding transformer, okay? So from the stator, I will have the 70% of the power, and from the rotor, I will have something like 30% of the power, okay? So I will have 70%, 30%. That is the reason the size of the converter is normally the 30% of the rated power, okay? What else? I will have two protection. The first one is the crowbar, okay? And the second one I will have here between the rectifier and the inverter. I will have, the first one is the crowbar and the second one is the chopper, okay? The crowbar is for protecting the machine, is for protecting the converters, okay? Is for protecting the converters. Okay, so in order to carry out the modeling of this machine, I need to take into account my first component, the wing. The wing doesn't have differential equations. Okay, what about the blades? For the blades, I don't have differential equation. Okay, but pay attention to the gearbox. For the gearbox, I will have 3 differential equations. Okay, for the machine, for the doubly fed induction generator, I will have 6 differential equations. For the converter, no equations, no differential equation, and for the filter, I will have 2 differential equations. Okay, so for this reason, for the differential equation, I need to take the initialization. What is the reason I need to initialize the machine? Because I need to initialize the states and the inputs. Okay, for the initialization process, the derivatives, for instance, the derivative of the speed are equal to 0. It means I am analyzing the steady state condition. Okay, in spite of the fact that I have a dynamical model, if the derivative are equal to 0 means is steady state analysis. Okay, so in order to carry out the initialization, I will start the process from the right side to the left side. Okay, so first of all, I will start with the power grid. What is the output of the power grid for the initialization? Is the stator voltage and the phase angle. Okay, later on, this is the input in order to carry out the initialization of the machine. Okay, and the output is the torque and the speed. Okay, the next component is the gearbox. Okay, for this case, I will have the angle is equal to 0 for the initialization, and the output for the gearbox is the torque, the turbine torque, and the speed torque. Okay, and finally, I will initialize the blades. Okay, so I will use this model. This is the actuator disk. What is the output? Is once again the speed. For the pitch angle, I will take this value is equal to 0 for the initialization. Okay, so we have already started the initialization of the power grid, and we compute the stator voltage and the stator angle, right? Okay, so now I want to carry out the initialization of the second component, is the double fed induction generator. Okay, so in order to carry out this initialization, okay, I will use the following data from the manufacturer. This is a real wind turbine. Okay, so I will have here the capacitor. What is the per unit system? I will have the base complex power, 2.21 MVA. This is the line-to-line voltage. This is the operating frequency. Okay, this is the speed. This is the wind speed. Okay, for the filter, I will have the resistance and the inductance. For the machine, this data come from the manufacturer. This is the stator resistance, the stator reactance, the rotor resistance. The prime means refer to the stator side, right? I will have here the prime. This is for the rotor. This is the magnetizing inductance. Okay. What about the number of poles? I will have 4 poles, right? And this is the design constant from the machine. And then I will have here my converter. For the converter, the line-to-line voltage is 480 volts, and this is the time constant, okay? This is the data for the gearbox, okay? In the beginning, I will have the turbine angle is equal to 0. This is the inertia, the turbine inertia. This is the inertia of the generator. It means I have 2 mass. Okay, so in order to model the gearbox, I will use the 2 mass model. Okay, this is the gain. Okay, I will have here the damping in order to model the gearbox. So starting from the dynamical model, I will make the derivatives equal to 0. I will have the steady state model. Okay, it means the steady state model is a particular case of the dynamical model. Okay, so for the aerodynamical model, it means the blades. Okay, I will have here the density, the wind speed, and this is the pitch angle. For this case, the pitch angle is equal to 0. What about the power grid? For the power grid, I will have the reference. This is the reference set points. This is the reference set points. Okay, so I will have 2 megawatts for the active power. Yeah, I will have 0.6 megabar for the reactive power. Okay. On the other hand, I will have here the voltage at the infinite bus. This is the magnitude and this is the angle. This is the reactance of the power transformer, and this is the reactance of the transmission line. So in order to carry out the initialization, I will go from the right to the left side. Okay.